Another physical property that is checked or can help us in standardizing our product is to check melting point. Um, this will apply usually to solid dosage forms, right? Solid dosage forms. So you want to check at what point does your product melt. So say BBA to say it mean a solid, not liquid. And you but BBA to me attach here. So who heat kakra time ben na ebeteki temperature ben ebeteki amana nanya they say I am an insu. That's basically what I'm talking about. That's a melting point. Now, it is also an indicative of whether your product is pure or not. And generally in chemistry, we say that for pure compounds, right, pure compounds would have highly defined temperature range. The range is usually around 0.5 to 1. But some more product, maybe I mean, the melting point here, 100 degrees Celsius, or let's do that too high, 50 degrees Celsius melting point. Yen yen say product here, you say product we capsule here. So we check melting point I say a year 50 degrees Celsius. So oh yeah, now we did something above 50, say 60, 70, 80. It means there's an adulteration. Bibi wo mu a emma melting point na kwasho. That means any product na product wine bibi atochima with the product. So usually melting point also gives an indication of purity. If your substance is pure, or if it's genuine or authenticated and it's pure, a melting point shouldn't change, or better still increase. When there are impurities in there, you see melting point going up and up and up. So it's one of the things that you can do to check if your product is pure or not. Of course, if you have a product you don't know the melting point, you have to establish it through experimentation. Make sure you do it over and over and over and over and over, and establish that for this product, every time you heat it at this temperature, it will melt at this. It will heat. So if you heat it, it will melt at this time, at this temperature. Exactly. So once you do that, you can repeat anytime you form a product. You just put it there, and then check. And that's just one of the ways of the melting point apparatus is what I've shown there. Swirl like that. You put a tube inside, collect your sample, put a tube inside. That yellow thing is not, that's the standard thermometer. Put a tube at the other side, and then you heat it. It will melt. Those who do chemistry a little bit, better than in a tube, which means it has melted. Then lose the temperature. That becomes a melting point. And then we have what we call the solubility test. This also, again, it's almost like the solubility one. So this one, you put a solvent and you put your solvent, your what they will we do a bit too. After say, time ben a bit mix it. Say, would you be too sulma, say water, alcohol, whatever solvent you're using, would you too it mean nana to make a frappe pepe. Then and nana, what time does it take to do that? Generally, we say that if it is not pure, then to have a lower solubility time, right? That's it. Then the next one is viscosity. That is the next one for you can also look at. This part of the physical methods. We know physical methods is viscosity. No. Back to viscosity. So basically, when we define viscosity, so this is a viscometer. Basically, what I'm looking at say, saying that how would I say how thick, sort of, or light the thing your product is mainly for decoction, liquid product. Send a yet thick so also as our fetch glacier, for example, very viscous. Also, I actually trying visa, but so glacier now in you see that there's not much of difference. So, or if you make a product, you're supposed to add glacier. You have added glacier to it. Now, when you added too much and you've added little, even viscosity can tell you. Once there's high viscosity, like glacier not also high, and it's our hasi, and you use this apparatus to check the viscosity of your product. Yeah. So how it resists flow. That's basically how we define viscosity for you. And it is always constant. Once it is one liquid or we are discussing, the viscosity should be constant. It cannot be varying. It cannot be varying. Yeah. And then another method is the specific gravity. Specific gravity, where it's more of density issue. Nti say if you weigh your sample, whatever sample you have, and you compare to a known weight of a known substance, usually we use water. So if you compare the density of your sample to the density of water, it should have a constant, and it has to be all the time right. Now I tell people that for when I was in Phyto, you could tell, you could always tell what solvent, whether the solvent you did was aqueous or not. Because if you did anything, so or sample near in sewer, the viscosity should be around 1 point maybe 0.006, 1.008, 1 point something. So we use alcohol to always be less than 1. Nti minim about, oh papa we use alcohol. See that be we use alcohol bia. I just have to check this one. If I check specific gravity, I can tell mama there's alcohol in your product. Because once there's alcohol in there, you can get specific gravity as 1 to be less than that. To always be less than that. So that's one of the ways you can use to check